So this is coming out of 2-1. Direction could just be simplify. Now, I don't know if you had one in particular that you wanted to see or type it that specifically gave you trouble. You can let me know if you think about it.
So this is not the one that I was talking about. The one I'm talking about is if you go to the assignment, it gives you 2-1, 2-3, 2-4, and
Mm-hmm.
2-5. But when I went to do the assignments on 2-1, it's like I got this.
Hold on, because I see in this section, I see combine like terms, and I see, and you saying it's not combine like terms, it's something else?
It is, but it's not the examples that you gave us on our lecture. And when I went over a couple of them, I kept getting them wrong. Yes, I probably don't. I probably need a little bit more practice in it, but at the same time, it's nothing like the exercises that we've been over, together, like in the lecture during class time.
Manager, let's see if I can see what you're talking about. So what's probably gonna be the flow of the course is that it's going to be hard for me to cover every single thing exactly to the T, but what you can do is when you see something that just not sitting right with you, you can bring that problem to class, or you can email me that problem and I can walk you through it, you know what I'm saying? So if that happens again, you know what I'm saying, especially since we won't see each other for a whole nother week, you might not want to wait that long. Yeah, you can just and I'm not sharing this screen. You can shoot me an email. Can you tell me how to do problem blank in 2.1 or something like that? You know what I mean? Whatever that problem is.
Yeah.
And then we'll do it like that. That'll probably help you out more than versus waiting for a whole week.
Okay.
So do you know around what number that was that you were saying that? Because I'm in 2.1 now.
It's a couple of them. What I'll do is, because I don't want to take up class time because there's other people listening too, I will send you some of the problems and see if you can help me out that way.
Okay.
And that's what kind of helped me a lot, because I know we had a missing day because of the snow. We have plenty of time to do the assignments, but I'm the type of person, I don't like to move on until I understand this particular exercise. So I didn't even do any of them because I wanted to get through that one first.
Okay. Okay. Yeah, we'll do it like that. Yeah, just go like that go from there. So whether it be you typing it out or sending me a screenshot, whatever the case may be, you send me those problems, I could walk you through them.
Okay, thank you.
Not a problem. All right, so let's do a few out of 2-1, and then we'll just, go through 2-2 and 2-4 and all that. So this is out of 2-1, simplifying expressions. If I want to simplify this, I want to write this expression in lowest terms possible. So I would distribute the -2, distribute this negative sign here. -2 times 4 is -8x. -2 times 7 is -14. Like I said, that negative has to be distributed as well. So be careful with that. A lot of times people will give that negative to just the 3x and they forget to give it to the -1. So that's going to be a -3x plus 1. All right. So once you've distributed and got rid of the parentheses, so now we can combine the like terms. -8x and -3x will be -11x. -14 and +1 would be -13. And that would be your answer. Nothing else you can do with that. All right, questions on that one? All right, see somebody in the chat? Okay, yeah, no problem, not a problem at all. All right, so here we have another one. Subtract 6x minus 1 from 3x plus 4. So make sure you're okay with the positioning. We want to subtract 6x minus 1 from the 3x plus 4. So it's going to be 3x plus 4 minus 6x minus 1. So that's how we would set it up. And if you want to put parentheses here, you could as well. All right. So now distribute that negative. And that'd be minus 6x plus 1. Combine your like terms. You have 6x minus 3x minus 6x be negative 3x. And then that'll be plus 5. Questions? Any questions? Do we need to see another one of those? Are we good to go? Y'all can let me know. Let's go here. All right, so we'll do a simple one of these first and make sure we compare what we just finished doing to what they're asking us to do in 2.2. Really 2.2, 3, let me see, 4, 2, 3. So 2.2 to 2.3, solving equations. So if we did this in the video, but just making sure we have an understanding here. First of all, there's a difference between simplifying and solving. So now you cannot solve these expressions right here. They're not equations. You only can solve equations, and that means you have to have an equal sign. And the only reason I'm bringing that up is because a lot of times once we do simplifying and then we do solving, a lot of people will try to solve this right here. But you cannot solve negative 3x plus 5. You have to have an equal sign to something else in order to be able to solve. So just throwing that out there, make sure you're not trying to solve when you're supposed to simplify. Because I've seen people come down and then all of a sudden they got x equal to 5/3, but there was nothing there to solve. You can only solve when you have an equal sign involved. All right. Other than that, the only thing you can do is simplify. All right. So when you're trying to solve, you want to get that variable by itself, and you're going to undo what's being done to the variable in order to do that. So you have x minus 5. So 5 is being subtracted from x. So to undo the subtraction of x, you're going to add 5. And when you're going to do something like that, there's the left side and right side of your equation, left side of the equal sign, right side of the equal sign. Whatever you do to the left side, you have to do to the right. So you're adding 5 to both sides. 5's cancel. X is equal to 20 as a solution. Also, don't forget that if you ever want to check, you can always plug it back into your original equation, and it should give you a true statement. 20 minus 5 is 15. 15 is equal to 15. All right. So that's the foundation of what you're going to be doing when it comes to solving your equations. You're doing the opposite operation, addition and subtraction. Our opposite operations, multiplication and division, are opposite. In other words, they undo what the other one does. All right, so if I have 2x plus 5 equal to 15, my goal is to get x by itself. But what's being done to it is that you're multiplying 2 and adding 7 to it. The most efficient way to handle this problem is to move the 7 first, subtracting 7 from both sides of your equal sign. Positive 7 and negative 7 cancels. 2x is equal to 8. And then from there, that's 2 times x equal to 8. I can divide. That's my 2 up. I can divide both sides by 2 now. 2 over 2 cancels. 8 over 2 is 4. So my solution is x equal to 4. All right. Any questions on that?
Can you do a couple with decimals, or is that another chapter?
I
Because
don't
I
know.
had a really hard time with, I don't know why decimals throw me off, but that's what I struggled with the most on the homework.
Yeah, not a problem. We'll get there. I might as well just do some ones without it first, making sure our foundation's straight. Then I'll throw some decimals in there.
Okay, thank you.
Yeah, most definitely. All right. So here we have 2x plus 3x minus 5 plus 7 equal to 10x plus 3 minus 6x minus 4. See fractions. Okay, there go the decimal too. Okay, cool. All right, so what I would do here is combine my like terms on this side, combine my like terms on this side before I move things across the equal sign. I would just simplify as much as I can on each side of the equation. So that left side, 2x and 2x will cancel, not cancel, excuse me. 2x and 3x will add together. They're like terms. That'll be 5x. And then negative 5 and positive 7 will be plus 2. On the right side, we have 10x and negative 6x, which is 4x. And 3 negative 4 will give us negative 1. So notice I haven't done any opposite signs or anything like that, because that's what you do when you're going across your equal sign. If I'm trying to take the 4 over there or take the 2 over here, I'm going to use opposite operations. But I haven't done that. All I did was just simplify everything that's on this side. So I just use the signs that I have, simplify everything that's on this side. Once again, just using the signs that you have. So now, when we are at this point, you want to get all right, so you want to get all terms with x onto one side and then all terms without x to the other side. So that should be your mindset when you look at this right here. We have x in two different places. You want to get all of your terms with x to one side, all of your terms without x to the other side. All right, so the way we do that, and I'll say this too, You have 4 different turns here. It doesn't matter which one you move first, and doesn't matter which side you take it to. As long as you do it correctly mathematically, you'll still get the same answer at some point. So I decided to move the 4x to the left side. So I'm going to minus 4x. 4x minus 4x will cancel. 5x minus 4x is 1x. So I have x plus 2 equal to negative 1. Then subtract 2 from both sides. X is equal to negative 3. And that'll be your solution.
I'm getting confused with the negatives when it comes to this. I understand you said it changes sign on each side of the equal sign, but I think I'm a little bit confused and I'm coming up with the wrong answer because of the negative or positive answer.
Okay, so when we're looking at this first, are you talking about right here, going from taking the 4x to the other side, or where are you talking about in this process? You muted.
Oh, sorry. And where it started out is a negative 1.
You said you're talking about right here?
When the 1 became negative, where
Oh, okay. You're talking about going from here to here. Okay, cool. Give me 1 second. I saw something in the chat as well. Okay. All right. I see that. I see you, Ms. Chu. I'll talk to you. If you want to talk after class, then feel free to stay back. So what happened here was when we talking about going from this green box to 4x minus 1, first thing we did was I did 10x minus 6x, which gave me this 4x right here. And then looking at those numbers, I have 3 and a negative 4. And so the 3 and negative 4 came together to give me that negative 1. So it's just like if I had 4 minus 3, that would be positive 1. Negative 4, or let's go here. 3 minus 4 would give me negative 1. So you think about the 4 was greater, so it was positive, so that means the result should be positive. Here the 4 is greater, it was negative, so my result should have been negative. So was that what you're talking about, that negative 1? Hopefully that helped.
Yeah.
Okay.
No, I see.
Okay, cool. All right, any other questions on this one before we look at another one? All right, let's go ahead and get to that decimal since that is what was requested. Before I do that one, let's do this one. I'll do that one next. Okay, so decimal one was asked of us, so let's do that one first. Now, if you want, you can keep the decimals involved, or you can do what we call, you can clear out the decimals by multiplying each term by, in this case, 10, because we have one decimal place here. So it just depends on if you want to go through all that or not. Let's go ahead and do that. So if I multiply each term, now whatever you multiply one term by, you got to multiply each term by that same thing. So I multiply each term by 10. And that's based on, like I said, the decimal place that you have. If I had 0.12, then I would be multiplying each by 100 because I'm in the hundreds place as far as my decimal is concerned. If it was 123, then I would be multiplying each thing by 1,000 because I have 3 decimal places, so I would be doing 3 zeros. So this is just the trick you would use if you're trying to get rid of your decimals. All right, so 10 times 0.1 is just going to be 1. So that'll be 1x minus 6x. 10 times 6 is 60. And then 10 times 19 is 190. So now we have our equation with no decimals at all. So if you don't like the decimals, then you can do this in order to get rid of them. All right. I'm going to combine the like terms. Negative 5x minus 60 equal to 190. Add 60. Negative 5x equal to 250. And then we can divide both sides by negative 5. X is equal to negative 50. All right. Questions on that? All right. I know we had a classmate that was asking about decimals. Did that help out any? Is that okay? Did you have one in particular you wanted to see? Is she gone? I guess she gone. Let's see, where's my fractional? All right, so let's do one that has a fraction involved. So here we have x over 2 minus 1 equal to 2/3 x minus 3. So we can handle this in a similar fashion that we did the one that had a decimals involved. So the first thing we want to do here is find the LCD. We're talking about the least common denominator of each denominator involved in the equation. So that's going to be 6/4. Remember, your LCD is going to be the smallest number that each denominator can divide into evenly. So 2 and 3 can divide into 6 evenly. Next, we're going to multiply each numerator by the LCD. And be careful with that. Like I said, it's going to be each numerator. And I want to emphasize that because sometimes people will leave out the numbers that don't have a denominator, but each numerator has to be affected by the LCD. So that's going to be 10 times x over 2 minus 10 times 1 equal to 10 times 2. I'm going to put an x in there. 2x over 3. Not putting 10. Why y'all let me write 10? I'm at 12. I mean, dang, not even 12, 6. I was thinking about another one. Sorry, supposed to be using my LCD there. I don't know where I got a 10 from though. So we multiply each numerator by 6. All right, any questions with the process so far? All right, so the next step is to simplify. So I just rewrote that. 6 will divide, 2 will divide into 6 and leave you with 3. 3 divides into 6 and leaves you with 2. And that's what you need to happen in order for you to be able to reduce. And then reduce and have a regular equation with no fractions at all. So that'll be 3x. 6 times 1 is 6. 2 times 2x is 4x. And 6 times 3 is 18. All right. Any questions so far? So now we'll go ahead and solve. Got that 3x minus 6 equal to 4x minus 18. And once again, we have x in different spots on different sides of the equation. So we want to get all of our terms with x to one side, all of our terms without x to the other. Once again, it doesn't matter which one you decide to move. I'm going to go ahead and subtract 4x from both sides. That's going to be negative 1x minus 6 equal to negative 18. Now I can add 6 to both sides. Negative x is equal to negative 12. Now don't forget you're trying to solve for x, not negative x. So I need to get rid of this negative, and you can just take it to the other side of the equation. So x is going to be equal to positive 12 because negative to the negative is positive. All right, make sure we're okay. All right, questions, any questions? Everybody good? All right, so here we have negative 2 times x minus 5 plus 10 is equal to negative 3 times x plus 2 plus x. And once again, we're solving. So distribute your -2, distribute -3. So it's -2x plus 10 plus 10 equal to -3x minus 6 plus x. All right, so I can add these two 10s together. And then also on this right side, -3x and positive x. So we got -2x plus 20, -2x minus 6. Now, once again, you want to add, where you want to get all of your terms with x on one side, all of your terms without x to the other. So I'm going to add 2x. And we have to be careful here. Notice 2x cancels on the left, but it also cancels over here on the right as well. So be careful because a lot of people are afraid to let math happen in this case, wherein they would cancel out the 2x on the left side, but then on the right x minus 6. And so be careful. If it cancels out on the left, then it has to cancel out on the right as well. So what we have here is 20 equal to -6. Our variables canceled out completely on both sides. And so when we have this situation, we know this is a false statement. All right, so if our variables cancel, you have a false statement. Your answer is no solution.
Can you scroll back up for like 1 second? Sorry. I was
Yeah.
trying to copy some of it down.
Not a problem. Yeah, that's the beginning of it, right? Yep. So when your variables cancel out and you end up with a false statement, your answer is no solution. All right. Scroll up a little bit.
Yeah, you want food? You finished?
Where did that problem go? Okay, there we go. All right. Everybody good? Okay. So looking at this one, we have 3 times x minus 4. Oh, hit the wrong button. 3 times x minus 4 equal to 3x minus 12. So we distribute the 3. And that's 3x minus 12 equal to 3x minus 12. Subtract 3x from both sides. And once again, we have a situation in which our variables cancel out completely. That leaves us with -12 on both sides. But this time, it was true. Because -12 is equal to -12. If I can write cancel. Yep, that one didn't work. All right, so if your variables cancel and you end up with a true statement, the answer will be all real numbers. All right. Questions? Any questions? All right. Anybody try any word problems? Let's see here. Word problems out of 2-4. So before I go and do a few word problems, questions on just solving equations. Need to see another one of any one of them. Is everybody okay for right now? You know, like I said before, like I said to one of your classmates, that invitation is for anyone. You know, if you have any problems with anything, and you know, if you want to set up a independent Zoom session like an office hour, we can do that. Or if you just want me to try to walk you through email, or maybe if I even need to set up or just create another video just for the problems that you have, you know, can't help you if you don't ask, you know, so it's all about communication. And once again, we only meet once a week. So you most definitely don't want to put yourself in a situation of waiting a whole week in order to get an answer. So most definitely, you know, hit me up and then try to get you through whatever problem it is that you're trying to knock out. All right. Let's look at a few word problems. And this is coming out of 2.4. All right, we have twice the sum of a number and 4 is the same as 4 times the number decreased by 12. Find the number. All right, so this one is kind of like it's just a word problem, but it's not really an application. It's just they give you some words to generate an equation. And so it's always good when you have something like this to figure out where the equal sign is. And it's most of the time, if you see the word is, or in this case, is the same as, that's where your equal sign will be. All right. So looking at everything before that will be the left side of our equal sign, and then everything after that will be the right side of our equal sign. So let's look at left side. It says twice the sum of a number and 4. So sum is addition, and then twice means multiply by 2. Let me do times 2, not x2. But you want to twice the sum of a number in x, a number in 4. So the sum of the number in 4 is x plus 4. and then you want to twice that. All right. Now on the right side of your equal sign, it says 4 times the number. Well, that's self-explanatory, 4 times the number, so it's going to be 4x, and then decrease by 12. That's subtraction. So we do 4x minus 12. All right, before we look to solve, questions. So once you have your equation, you go ahead and solve it the way we did the other problems before this. You can distribute 2, 2x plus 8, 4x minus 12. Now we can get all of our terms with x to one side, all of our terms without x to the other. Subtract 2x. Eight is equal to 2x minus 12 because we have 4 minus 2x on the right. Now we'll add 12. Twelves cancel. That's 20 equal to 2x. And then we can finish it off by dividing by 2. X is equal to 10. All right, questions before we look at another problem? All right, so we have a 48-inch stick. It's to be cut into 2 pieces so that the longer piece is 3 times the shorter. Find the length of each piece. All right. So let's look at what we have here. We have 2 unknowns. We have a, want to go red, and go red. Short piece, and we have a long piece. Now, what we don't want to do is call one X and then the other one Y. We want to keep the same variable, And the problems that you guys get, you will be able to write all of your unknowns in terms of the same variable. Like I said, you don't want to introduce multiple variables, because then you have to introduce multiple equations. Then you have to use a system of equations, and we don't want to have to do that with the problem that you guys are getting in this section. So we're going to go call one x, and then we're going to write the other one in terms of that x. So if you notice, the longer piece is described in terms of the shorter. It says that the longer piece is 3 times the shorter piece. So if I call the short piece x, that means the long piece is going to be 3x. So all of the problems that you guys get in this section will be able to be established in this fashion. Once again, you don't want multiple variables. You only want one variable, and then write the other one in terms, or the other ones in terms of that unknown piece. All right. So when you look at this board that we have here, or the stick, you have a short piece and the long piece. The short piece is x, longer piece is 3x. But don't forget that the whole thing is 48 inches. So if you're talking about writing an equation with this diagram in mind, or this thought process in mind, we have the small piece, short piece plus the long piece should be equal to a total of 48 inches. So x plus 3x is equal to 48. All right. Is everybody okay with that before we go ahead and solve? All right, so x plus 3x is 4x. There we go. And now we can divide both sides by 4. X is equal to 12. All right, so now we have to be careful here. We have x equal to 12, but it says find the length of each piece. It didn't say find the length of x. So you got to make sure that your answer actually answers the question. So we know x is equal to 12, so that means the short piece is going to be equal to 12. But then the longer piece has to be 3 times 12, which is 36. So the short piece is 12 inches, the longer piece is 36 inches. And don't forget, if you add them together, they're supposed to give you that 48. All right. So let's do at least one more. Oh, missed my number, 434, 435. All right, so Congress had a total of 435 Democrats, 435 Democratic and Republican representatives. There were 59 fewer Democrats than Republicans. Find the number from each party. All right. So we know we have two parties. So it's two unknowns. We got the Democratic Party and the Republican Party. So one of them is going to be X and the other one is going to be written in terms of that X. So there were 59 fewer Democrats than Republicans. So that means I would let the Republicans be X and do X minus 59 for the Democrats. Another way of looking at it, and we're only going to explore one of the ways, I could have called the Democratic Party X and then the Republicans X plus 59. So it just depends on how you were seeing it. As long as when it comes to the relationship, there were 59 more in the Republicans, in the Republican Party than the Democrat. All right. So now there was a total of 435 in Congress altogether. So that means X plus X minus 59 is equal to 435. Got your Republicans plus your Democrats is equal to 435. All right. Nothing is holding those parentheses there. I just use them to signify what part came from what. So I'll just go ahead and add my like term. So that's going to be 2x minus 59 equals 435. I'll write it down here. All right, adding 59 to both sides. $494 divided by 2. All right, so then we'll have 247 as our solution.
So I did that like a completely different way.
Mm-hmm.
But I'm pretty sure what I got is like accurate, like it's correct. So like reading that automatically, I'm like, okay, well if your total is 435 and there's 59 less, then what I did was 435 divided by 2 and added 59 to the 1, and I got 274 Republicans and 188 Democrats.
All right. Now you said how many Republicans?
I got the 247.
Uh-huh.
Because if you have like the total, I don't know, I do math. My brain does math weird because like you have the total, right? Like this is your number. If you cut it in half and there's only 59 more, whatever they are, then it's like the half plus like the 59.
Mm-hmm. And so that's where this came into play at 2x, and we actually cut it in half right here. And then we're going to add 59. Well, in this case, we're going to subtract 59. and get that value. Yep.
Okay.
Yep, you did the same thing.
It's just like my brain does it like weird ways. That's why like some of this is I'm like it's hard and I'm just like what? But then like when I like get to read it, I'm just like, oh, like I can do that, like that's fine. I also get the same answer, but it's like not the way it's supposed to be done.
Right. Well, the thing about it is there are multiple ways of doing it, but if you're talking about setting it up as an equation, now if you had an instructor that was going to hold you to setting it up as an equation, then this would be pretty much the only way you can do it. But when you start talking about your rationale and figuring things out, like the mind can work out a whole bunch of different things if we let it. And just like a lot of people, if they start doing construction and everything like that, they don't have to set up an equation to figure out different things. They just they just work it out. But if you had to set up an equation, there's only like one or two ways that you can actually do it to set up an equation. So yeah, that's fine as long as you're getting the right answers. I'm fine with it. But if you need a solid way to get those answers, this would be the background behind what you would do.
Okay.
All right. Questions? Any questions? Where's that B section? Looking for something that I don't see it. Okay. So that's it for chapter 2. Why is this not in there? Looking for something in this book and I'm not seeing it. And I thought I saw it. That's the R section. All right, let's do this. Yep. Looking for, that's my percents. Oh, I don't want to do that yet. So I wanted to touch on percents. Not looking to finish it off, but at least touch on it today. So let's do this first. All right, so let's touch on ratios and percent. Um, and looking at ratios. And where did my thing go? As a matter of fact. Sorry, because I'm looking for it in this book and I'm not seeing it. So I wanted to make sure I cover what they told you to cover versus me just pulling stuff out.
I have like a discrepancy with the book, I guess.
Uh-huh.
Like if
What you
you
got?
look in the index, it doesn't necessarily coincide with the exercises.
Oh yeah?
Yeah, I was like trying to like look for some. Shut up! You're being so bad. You're getting yelled at right now. I'm sorry. Um, yeah, I was like trying to look up some exercises and like the page number and like the 1 point whatever. This was like a while ago. Like they didn't like it didn't match up at all.
Okay. So I'll take a look at that because I was looking for, that's exactly what I was looking for. I was looking for this B4 4.1 and I didn't see it. But everything from chapter 1 up to chapter 2 was lining up. So that's why I just been flowing with the exercise in the book. And that's what was holding me up just now. So I'll take a look at that further. I didn't, like I said, I didn't know that that was happening. But I know that that's what they want us to cover. All right, so your ratio is the quotient of two numbers or two quantities. It's no different from a fraction. And we have three ways that we can write a ratio. You can write A to B, A colon B, or A over B, and all three of those represent the same thing. Notice that the first term coincides with what's on top of your numerator. All right, so if they want us to write this as a fraction, we have the ratio of 2 parts salt to 5 parts water. It's just going to be 2 over 5. If we have 12 colon 18, that's still 12 to 18, so that'd be 12 over 18, but that can reduce. 6 times 2, 6 times 3. 6 is cancel, so that'd be 2 to 3. Here we have 2.5 to 3.15. And notice we have decimals involved, so it's not really in fractional form if you have decimals in your fraction. So we need to multiply, and we mentioned multiplying decimals in order to get rid of them. I have 2 decimal places right here, hundredths place, have 1 right here, which is the 10th place. So I multiply by the most, which would be that 100. Because whatever you do to the bottom, you do to the top. So you can't multiply the top by 10 and then the bottom by 100. So you have to multiply them both by 100. That'll be 250 over 315. That's 5 times 50. 5 times 63. Yeah. 5's cancel. That's 50 over 63. Miss Pennington, do you know or remember where you started to see the discrepancy, whether it be what chapter or whatever?
Oh God. No, it was a while ago. It was like when I first got the book because my book came unbound, and when I opened it, it went everywhere, and I was trying to make sure I put it back together right, which it is. It's numbered completely correctly. But then I started noticing, like, when we started getting into chapter 1, I would try and look for things, and I was just like, where is this?
Right. Okay. Because your book cover is red, right?
Yeah, let me grab it really quick. Hold on one second.
Yeah. I want to make sure I have the same book that you have. This says Fundamentals of Reasoning. Math
Yeah, because
130.
I know you
Custom
said that we
edition.
didn't have to get the hard copy, but I enjoy being able to have that.
Yep.
Plus, that one's resellable for money, so.
Right. Gotcha. So I'm gonna see about that and let you know what I find.
Hold on, because I got all my textbooks in this big old box. And I had to put mine in this big old binder. So. Alright, y'all should be able to see a little bit better now. So, this one?
Yep.
Yeah, it doesn't match up.
Gotcha. Okay, so I'm gonna take a look at that and see what's going on. Yeah. Appreciate that. All right, so proportions, just a statement that two ratios are equal. So in this case, 1 over 2 is equal to 4 over 8 would be considered a proportion. All right, so the way we can test if we have an actual proportion is by using the cross product. And cross product says if I have A over B equal to C over D, I would take my denominators up to the opposite numerator and multiply, and those numbers are equal, then I do have an actual proportion. So if I go back to that example of 1 over 2 equal to 4 over 8 and do the cross product, I have 1 times 8 on the left, 2 times 4 on the right. 8 is equal to 8, and that means I do have a proportion. All right. So if I have 45 over x equal to 5 over 7, and I wanted to solve, I would use the cross product relationship, taking my denominators up. So on the left is 315, on the right is 5x. Divide by 5. And x is equal to 63. All right. Let's do another one. All right, you got 3 over 8 equal to 63 over x. So once again, same thought process. You have these two fractions set equal to each other. You want to know what the missing piece is, cross multiply. So we have 3x equal to 504. 5 by 3. X is equal to 1, 20, that's 8. No, 6. 8 and 2, 24, then that'd be 8. All right, questions. All right. Do one more like this. X minus 5 over 3 equal to x plus 2 over 5. Once again, cross multiply. So it's going to be 5 times that whole numerator equal to 3 times x plus 2, which is that whole numerator. All right, so now we can distribute. That's 5x minus 25 equal to 3x plus 6. All right, minus 3x from both sides. Remember, your goal at this point is to get each term with x on one side, each term without x to the other. So I decided to subtract 3x from both sides. Now I'll add 25 to both sides. Which gives me 2x equal to 31. Divide by 2. X is equal to 31 over 2. All right, so here it says on a map, 5 miles corresponds to 2 inches. How many miles correspond to 7 inches? So we want to make sure that when we set this up that we're consistent in our setting up, right? So we have miles to inches. So make a decision. Are you going to do miles over inches or inches over mile? Doesn't matter. As long as you stay consistent, you'll still get the same result. I decided to do miles over inches. So that's going to be 5 miles over 2 inches. And then it says how many miles. So miles will be my unknown, corresponds to 7 inches. So that's how you would set up your proportion. As long as you stay consistent across the board or across both fractions, both ratios, then you'll still get the same result. And then from there, I have my proportion. I can just solve it by cross multiplying. Matter of fact, I'll bring that down here. So it'd be 35 equal to 2x. Divide by 2. Be 17.5 inches.
Couldn't you also do like 5 times 3 plus 2.5?
So 5 times 3. Hold on, you said 5 times 3?
Yeah, so if 2 inches equals 5 miles and 1 inch is 2.5 miles, so 5 3 times plus 2.5.
Oh, okay, I see where you're going. Yep. You want to break it down that way. Yep. All right. Let's see. Let's do one more. I guess I'll write it out since they did. Standard dose. All right, so we have the standard dose of antibiotic is 4 cc's for every 25 pounds of body weight. At this rate, find the standard dose. Standard dose for a 140-pound woman. So once again, you just want to be consistent in how you set it up. If I'm going to do cc's over pounds, then we just have to be consistent when you set up your proportion. So we're looking at 4 cc's for every 25 pounds. Then it says at this rate, how much dose, what is the standard dose for a 140-pound woman? And cross multiply once you have your set up. So that's 4 times 140, and then 25 times x. So that'll be 560 equal to 25x. Divide by 25. X is equal to, and I should do 22.4. All right. Questions on anything I've said up to this point? Why is this not coming up? All right, so that's just the start of what that is, 4.1, this B4, 4.1. I'm not sure, as we were discussing a few minutes ago about the page numbering in this book. Not sure what's going on with it and why.
What sections were these we covered again? I'm sorry.
You talking about what we just did?
All the sections we just covered. I just like to write them in my notes.
Okay, the last one we did was just 4.1. I'm trying to get back to my math lab to show you. Oh, where my tools at?
Does the textbook online, like, were you looking at the online version or the printed version?
I was looking at the printed version.
I wonder if the online version matches up.
Well, that's what I was going to do. I just wasn't going to take up you guys' time to start, trying to figure that out. I was assuming since they gave me a book that it was going to match up. And I guess that was my fault for assuming that. But yeah, so I'm going to line things up. We'll see if the e-text line up and everything like that. Right now, I'm trying to get into the assignments so I can map out some stuff with you guys before we get out today. But for some reason now it doesn't want to come up. I guess it got to be my math lab, because if I didn't have my internet, I wouldn't be talking to you guys. All right, so it's not going to come up. All right, so the other sections that we did today was we just reviewed 2.1 through 2.4. And okay. Asked for too much. Okay. So where we are now, we did chapter 1, and we've talked about chapter 2, and so it's 2.1 through 2.4. I was trying to map out see what chapter 1 went to, but my math lab wouldn't pop all the way up, so it's all good. And the next section we had was it's like B4, and it's 4.1 through 4.8. All we did today was just a 4.1 though. So there's a test. Test 1 is on chapter 1 and chapter 2. 1.2 through 1.5. There it goes. So chapter 1 goes 1.2 to 1.5. All right. 4 through 8, yep. And as a heads up, like I said, this goes to 4.8. That will be test 2 by itself. Chapter 4 is that B4. Chapter 4 will be test 2 by itself. All right. So test 1 has been posted. Remember I said you can do that on your own. Just make sure that after you do it, that you send me your scratch work, picture of your scratch work, or scan it, whichever way you want to do it. And yeah, that's it. And like I said, I'll check out, what's going on with these sections in chapter 4, so we can make sure we have something to reference as far as lining up is concerned. So are there any questions, concerns, comments before we go close out the day? So make sure that you guys, right now you should be trying to get that chapter 1, it's not chapter 1, that test 1, knocked out as soon as possible. Right now, I don't have a solid due date on it. Trying to give you guys a chance to get in there and knock it out. That's why I didn't pull back. So, we supposed to let out, what time are we supposed to get out of here? I think it's like 9 something, right? 9:45, something like that. So try not to push you guys all the way to that time. And so you see that we have time, a whole bunch of time that we could have done some more work. So, but I understand, it's only but so much I can hit y'all with in one day. I don't want to, overdo it. So I'm supposed to go, 9:45. So I'm just trying to let you know that I am thinking about, the actual situation versus just saying, let me cram a whole bunch of math and throw it at them. So let me see, questions, concerns, comments, anything, anybody before we go.
So there's no due date on it, but it's definitely like, so it's not too late if I do it like this weekend.
No, not
Okay.
too late at all. Not too late at all. At some point, I am going to put a due date out there to close out, chapter 1, chapter 2 stuff. Just haven't done so yet. Trying to give everybody a chance, because I know it's kind of weird, this one class a week thing, and then it's late at night, and I'm just trying to give everybody a chance to get in there and get comfortable, get in their flow. So let's see, because chapter 4, chapter 3, 6. And so we have a little wiggle room. Just got to make sure I don't, overextend. Yep. So that being said, that's it for today. Next class, we will get all the way into chapter 4 stuff. Some of those sections could have been put together. So I know it sounds like a lot with 8 sections, but when I look at the content, like a lot of the stuff could have been done together, like percent, and like percent is the next section. Percent fraction, normally that's a section. Percent and percent fraction are normally together. And then percent equations and proportions. Yeah, a lot of these things could have been done together. So we'll see. Like I said, try not to overdo it, but a lot of chapter 4's contents, those sections could have been done, together versus making them whole sections. All right. So with that being said, I will go ahead and let you guys go for tonight. Have a great week. Don't forget, if you have questions, you don't have to wait until next week to try to get those questions answered. Had an emergency in my family this week, so it's hard for me I am a little behind on some of my emails this week, but normally I'm on top of things like that. So, but other than that, we'll go ahead and knock this stuff out, and hopefully everybody come out of this thing with an A. I think that's what everybody's shooting for, right? Getting an A. So outside of that, I will see you guys on next class. You have a good one. Have a great week, and enjoy the Super Bowl. All right. Everybody take care.